So this is the 4-3 lesson. You're going to find out that today, as I feel like it's been for most of the year, that the Algebra 2 part is not very difficult. It's the old school stuff, the factoring, plugging stuff in and doing order of operations that we're not the best at, that we need to work on. So today we're going to be dealing with these rational expressions, and I'm going to talk to us about the original like fractions first, and then we're going to apply that to uglier numbers, but the same process. So when you get 10 over 15, you should have been taught in middle school to reduce this, and maybe you should see this as a 2 times 5, and this one as a 3 times 5, and then what happens is, instead of multiplying by 5 and then later on dividing, because that's what this bar means by 5, we go, no, forget that. I don't want to do that. And so we reduce this fraction to really 2/3. What do I know about these two numbers? They're exactly the same thing. They just look a little different. This is the reduced form of it. As long as you have something on top that has something common at the bottom, you can cancel it out. But it has to be identical, right? So, or you could do it here. What do 10 and 5, 15 have in common? 5 go into both of them. 5 goes in that 2 times, 5 goes in that 3 times, and you still end up with 2/3. So different ways of showing your work, but should get to the same answer. Well, how does that apply to what we're doing today? Well, let's say I have x plus 2, x minus 3, and down here I have x plus 4, x and then x plus 2. So what would happen is I would actually be able to cancel things out. So I could actually say, hey, this x and this x cancel out. This x plus 2 and this x plus 2 cancel out, simplifying to x minus 3 over x plus 4. However, I did miss something. See, when I say two things are equal, that means that no matter what happens, if I plug an x into this one and I plug an x into this one, I should get the same answer. Well, I can plug 0 into this. If I plug in 0 into this equation, it's fine. 0 plus 4 is 4. 0 minus 3 is negative 3. So if you plugged in, if you said x equals 0 over here, you would get an answer of negative 3/4. But if you plugged 0 into this side, you would get 4 times 0 times 2 in the denominator. And what would happen is 4 times 0 would kick to 0, and then 0 times 2 would go to 0. And so over here, I would have a denominator 0, which my calculator would say, error, you can't do that. So that means these two things right now are not equivalent. The way that I make them equivalent is I have to write their exclusions. I have to go, wait. These two things are the same as long as your x doesn't equal negative 4. That would make that 0. X couldn't be 0 because that would make that 0. Or x can't be negative 2. These are called exclusions. Now that I wrote the exclusions, now these two things are exactly the same. If you put any x into here and you put that same x into over here, these two things will give you the same answer at the end, as long as you don't ever use one of these numbers. Does that make sense?
Yeah.
Does anyone have questions on what we just went over? This is still the same stuff that we've done, as you've done in the past, just simplifying a fraction, but now just uglier stuff with it. All right, what form was this given in? Anyone? What form did I give that to you in?
Factored.
It is in factored form. Perfect. What do you think form they're going to give it to you in for the, when they give this for your homework, what form do you think they're going to give it into you?
Standard.
And what are you going to have to do before you can
Factor it.
even Yeah, and that's where we're going to run into trouble for some of us, is we're not going to be able to factor as well as we need to. But you can see canceling out an x with an x is not that hard, I don't think. Canceling out an x plus 2 with an x plus 2, I don't believe that should be that hard or more than what anyone in this class can handle. However, changing things from standard form into their factor form correctly and then being able to cancel, I think going from the standard to the factored is where we're going to have our issues. So here's an example of what that looks like. I'm giving a weird example for the factoring on purpose, just to remind you of some things that you can do. So right here, we've got to factor both the top and bottom. So I'm going to work with this top for a minute. And I don't like the way that it's written, so I can change this. I want this x squared pulled up front, and as long as I keep the negative with it, it's cool for me to move it. I want this 4 in the back, as long as I keep the positive, which is not written there. That was not written, it's understood. With it, I can move it around. Now, I still don't like that this has a negative attached to it, so what am I going to do? I'm going to just pull out a negative, and then negative times x squared gets me to negative x squared, and then negative times a negative 4 would get me back to a positive. So if I distribute this back, it gets me the same thing that I started with over here. So that means that these two things are the same. Now the reason I wrote it like that is because I can then go negative, and then hopefully you do spot that this is a difference of squares. So this is going to be x plus 2. Over here will be x minus 2. And now I'm finally finished factoring the top. I can work on the bottom. Again, it's just factoring. This says different signs. One's plus, one's minus. This says the bigger one is positive, so the bigger one's going to go here. And then I need two numbers that multiply to 10, but subtract to 3, which would be 5 and 2. And then I look at here, and before I start crossing crap out, I need to do my exclusions. And I say, okay, wait, x can't be negative 5, and x can't be 2. That way, in case I cancel one of them out, which I do, I still know what x can be. So my final answer would be negative x plus 2 over, oops, that doesn't really matter, x plus 2, these parentheses do matter, over x plus 5, where x cannot equal negative 5 or 2. And whoop, there's my final answer. Got to include that negative. Does anyone have questions on what I just went over on that? Morris, did you have a question, or were you saying no?
I was going to say no.
Okay. All right. Now let's talk about some more rules. If you notice, every one of these rules is back from like middle school era. They're just things that we were supposed to do. Like if I said 2 over 3 and I times it by, let's say, 9 over 10, and I wanted to multiply those. You could multiply this and make this become 18 over 30. I hate that way because then you have to look at these two numbers and try to figure out what they have in common. And especially when numbers get bigger, you have more room to make error. I like to do my simplifying over here. And the way you can simplify is as long as something is in the top and it's multiplication between them, and something in the bottom have a number in common, you can simplify it out, meaning 2 can go into 2, and 2 can also go into 10. So I can reduce both those. This 2 goes into that once, 2 goes into that 5 times. Same with the 3 and the 9. 3 goes into this once, 3 goes into that 3 times. It doesn't have to be its number. You'll see what I mean in just a second. And then when you multiply, you get 3 times 1, which is 3 over 5, which is what this would reduce to, because 6 goes into both of them. So you divide that by 6, and you would get 3/5. Either way, you get the same answer. I just like doing my reducing over here. We're going to need to do our reducing with the stuff that I'm going to teach you today over in this section. This same thing actually applies even if I have bigger numbers. Let's say I had a 7 over 10 times 5 over let's say I had something like this. You can actually reduce things. The rule is all has to happen is one has to be in the top and one has to be in the bottom, as long as all of this is multiplication, which all it is multiplication. So like I look at the 7, I go 7, do you have anything in common with 10? No. Does 7 have anything in common with 3? No. Does 7 have anything in common with 49? Yes. 7 goes to 7 once. 7 goes into that 7 times. 5 and the 10 have something common. 5 goes into that 5 one time. 5 goes into that 2 times. And then finally, also the 2 can cancel out with a 2, leaving me with a 1 here and a 1 here. And 1 times 1 times 1 is 1 over. 1 times 3 is 3 times 7 is 21. So 1/21 would be my final answer for this one. Whereas if I'd done it the other way, I would have to be doing basically 70 over 49 times 3. So that'd be what? 147. And then, so I'd have to reduce these two, and I should be able to reduce it down to that. So, I mean, I would rather deal with the smaller numbers than have to deal with the bigger numbers like that at the end and have to reduce all that. Does anyone have questions on anything that I just talked about in that? That is basic fraction work. We're going to have to apply it to much larger and nastier numbers here in just a second. All right, so if I had product, by the way, if they in the book it says what is the product of this and this. Product just means multiplication. So if you see that word tonight, it just means multiply them. All right, so for this one, you should be able to see, hey, does the 2 have anything in common with the z, or the 2xy have anything in common with the z? No, it doesn't. Does the 2xy have anything in common with this down here? Yes, it does. 2 goes into 2 once. 2 goes into this twice, so I can reduce the numbers. X can't simplify with anything, but the y can cancel out with a y. Now, actually, I did mess up because before I start canceling, I need to look at my restrictions, because when I cancel some stuff out, my restrictions might go away. So I have to remind myself that y can't equal 0 and z can't equal 0. I got to make sure I write those restrictions. Okay, now I'm free to just start smacking stuff off. Does the 3 have anything in common with anything? No, it doesn't. Does the x squared have anything in common? No, it doesn't. So then I multiply top times top. So all I have left up here is x times 3x squared, which turns into 3x cubed, over z and 2 and z. So that turns into 2. And then z times z is z squared. So this would be my final answer, including those restrictions. And the final example that I'm going to do, and then I'm going to give you a chance to try some on your own, is this 5x over x plus 3 times x squared plus x minus 6 over x squared plus 2x plus 1 times x squared plus x over 5x minus 10. And what you should realize is these are all in standard form, which is not good. So the first thing is going to be to factor them. The first equation is already factored for us, so that's really good. Then we need to change this. This says different signs. This says the bigger one is positive. This is how fast it should take me to factor these guys. I need two numbers that multiply to 6 but subtract to 1, and the bigger one is positive, so x plus 3, x minus 2. This says same signs. This says they're both positive. Any two numbers that multiply to 1 but add to 2. And another way that this could be written is maybe x plus 1 squared. You need to know that times. And then these guys have a GCF. They have an x in common. And when I pull that x out, I'm left with x plus 1. Because remember, this times this gets me to x squared, but then this times this gets me that final missing x. And then on the bottom, I'm going to have these guys both have a 5 in common. That's the greatest common factor. And then I'd be left with x minus 2. Now, before I start smacking stuff out, I'm going to do my restrictions. What can x not equal? Well, right here, it can't equal -3. What can it equal not here? A -1. Same one here, no need to list it twice. And finally, a +2. These are my restrictions. So now I can start canceling stuff off. 5x, do you have anything in common with this? Down here, no. Anything in common with this? No. Anything in common with this? Yes. 5 and 5. Leave the x, it doesn't have anything in common with anything. X plus 3, cancel out with x plus 3. X minus 2, cancels out with x minus 2. And finally, x plus 1 cancels out with one of those, not both of them. And then I go, okay, what's left over? Well, on the top, I have x and an x, which is x squared over. The only thing I have left on the denominator is x plus 1. And then I have the where x cannot equal -3, -1, or 2. And that would be my final answer. That is the simplified version of all of that trash. Does that make sense?
Do you have one more we can do a lot slower?
What part is getting you? Because I'm not doing, the only thing I'm doing fast is factoring. That's it. Everything else is
like
just,
right after factoring.
so like, do you see this right here?
Yes.
You're just looking at the bottom. Does it have anything in common with x plus 3?
No.
Does it have anything in common with the x plus 1s?
No.
Did it have anything in common with the 5, x minus 2?
Yes.
Yeah, the 5. 5 canceled out with the 5.
Okay.
Does the x have anything in common with anything down there? Nope.
No.
Do you see the x plus 3, the x plus 3? Those are the same thing.
Mm-hmm.
You see the x minus 2, the x minus 2.
Mm-hmm.
The x plus 1 cancels out with one of the x plus 1s, not both of them.
Okay.
And then at the end, you just multiply what's left over in the top. The only thing that's left over is this x, and x times x is x squared. And the only thing left in the bottom, this wasn't there, don't worry about that, was this guy.
Okay, now I see it.
Everything else canceled out. So if I had to do this in steps, it would be first, factor. Second, look at your exclusions. Third, cross crap out. And yes, I do have one, but you're going to try this one on your own. So I'll give you 2 or 3 minutes, and then I will come back on and I will go through this and we'll get to the answer. So you got 2 or 3 minutes. All right, so you should have figured out that the first one was already factored. The next one, you'd have to say, okay, first you always try to do GCF, right? So they have a 3 in common, then you're left with x minus 6 over, these guys have a 6 in common, and then you'd be left with x minus 3, and then times, and then this should have been x squared over, these guys have a 4 in common, and you'd be left with a x plus 3. Does everybody agree or anyone disagree with what I did there? All right, so what would cancel out? Does an x plus 3 have any, actually before I do that, let's do our x, don't forget these. 0 is the first one. X cannot be 0 because if I put a 0 in here, 0 times 4 would be 0. So that's, x can't be 0. X can't be 3, and x can't be negative 3. So you can actually put a plus or minus 3 here, or you could list 3 and negative 3. Doesn't matter. All right, so this x plus 3, it's not going to have the bubbles. I had to put those in there maybe just to help me out, but don't have to. X plus 3 cancels out with that x plus 3. This 3 cancels out with that 6, so this turns into a 1. This turns into a 2. Yeah, right? All right, rub down there. And then what you're supposed to see here is this x minus 6 has nothing in common. And then this x squared, really this is x times x. There's two x's that are here. So this 1, this is x to the first power. This 1x can simplify one of these x's. So you can have 1x left over like that, or I scratch these out and put a 1 there. So like that. So there would be an x left in the top, just 1 now. So then on the top, I would have an x left and an x minus 6 left over, that's the only things that are left up top, this one and this one, over 4 times 2, which is 8, times 4, which is 32, and then x minus 3. And then that would be your answer with those exclusions. If you have like x squared and then 5 times x cubed, whatever, 10. Okay, you have 2 x's here, you have 3 here. So these 2 are going to be completely gone, leaving you with 1. 2 of these are going to be gone, leaving you with an x left over. I hope that makes sense. And then 5 goes into 5. 5 goes into that twice. So you'd end up with a final answer of 2 over x, except where x cannot equal 0. That's what your homework will be on tonight. So go ahead and practice that. We'll go over it tomorrow in class. And tomorrow's lesson is very similar to what we did today. Questions before you leave? All right, have a good day.